again, hello students, I am Rajneesh Kumar, working as an assistant professor in NIT Pharmacy Institutes. I am again here to discuss some topic of pharmaceutical organic chemistry of third semester. The topic includes effect of substitution on reactivity and orientation of monosubstituted benzene. In the previous lecture, we have already discussed reaction of benzene, which includes mainly electrophilic substitution reaction. We have discussed halogenation, we have discussed nitration, sulfonation, Friedel-Crafts acylation and alkylation of benzene, along with possible limitations and their mechanism. We have already seen that electrophilic substitution reaction of benzene includes two steps, or you can say three steps. In the first step, generation of electrophile is there. In the second step, attack of electrophile on the benzene ring, and in the third step, removal of the proton from the benzene ring occur, and at last we are getting the same products. Okay, now come on the electrophilic substitution reaction in substituted benzene also. So, the substituted benzene ring also goes in the same way as benzene in case of electrophilic substitution reaction. Okay. So, without wasting time, I am just coming on that point. The reaction of substituted benzenes are similar to those of benzene, but it will take place faster or slower than benzene, depending on the substitution pattern on the benzene ring. Means you can just imagine that, or you know that benzene have the 6 carbon and all the 6 carbons are equivalent, sp2 hybridized. Okay. If there is no substitution on the benzene ring, then all the carbons are equivalent, sp2 hybridized, and coming electrophile can attack any of the carbon of the benzene. Okay. In the common electrophilic substitution reaction of benzene, but if there is a substitution already present on the benzene ring, then there is possibility that coming electrophile can go at ortho position, at meta position, or at para position with the same reaction rate, or reaction rate may be increased or reaction rate may be decreased. All these things will depend on the substitution which is already present on the benzene ring. Okay. So, there is mainly two effects which a substitution can produce on the benzene ring. First, it can alter the reaction rate. It may increase the rate of the reaction, it may decrease the rate of reaction. It can also influence the orientation of the coming electrophile on the benzene ring. Okay. So, coming electrophile will goes on ortho, meta or para. It will be decided by the substituents which is already present on the benzene ring. Okay. So, we can classify the substituents which are already present on the benzene ring in two groups. Number 1, activating group. This is also called ortho para directing. Number 2, deactivating group. This is also called meta directing. Means activating groups includes those groups which can cause increase in the reactivity of the benzene towards the electrophile, and it always induce the orientation of the coming substituents on the ortho and para position. The second group include those substituents which can reduce the reactivity of the benzene ring towards the coming electrophile, second coming electrophile. They generally direct the coming electrophile to the meta position. Okay. Halogens are exceptions. They are ortho para directing, but deactivating group. Okay. It must be taken care of that. Okay. So, two types of, now first of all we will go for the effect of substituents on the reactivity of the benzene ring. Okay. So, two types of group, activating and the deactivating group. If the benzene ring is attached to the group which can increase the electron density on the benzene ring, then it will increase the rate of the reaction, electrophilic substitution reactions of benzene towards some electrophile, okay, because they have the tendency to donate the electrons towards the benzene. The second type of group is called deactivating groups. Okay. These groups when attached to the benzene, then they decrease the electron density on the benzene ring, because they have the tendency to withdraw the electrons from the benzene. Okay. I hope that you can understand in. Okay. So, as I said earlier that activating groups are ortho and para directing. They will direct the coming electrophiles, second electrophiles on ortho and para position of the benzene ring. Deactivating groups always a meta directing group, they will direct the coming electrophiles on the meta position of the benzene ring. Okay. The halogens are in a class by themselves being deactivating, but ortho para directing. So, they are exceptions, I have already told you. Okay. So, the first we will discuss that what are the effect of substituents on the reactivity of the benzene ring. So, I have told you earlier that reactivity of the benzene ring towards the second electrophilic attacks may be altered because of the presence of substituents on the benzene ring. These involves donation of electrons towards the benzene ring or withdrawing of the electron from the benzene ring. By donation of electron towards the benzene ring, the electron density of the benzene ring will increase. By withdrawing the electron from the benzene ring, the electron density on the benzene ring will get decreased. Okay. So, generally there are two mechanisms which or you can say two factors which can influence the electron density of the benzene ring, or we can say mechanism through which electron density get increased or decreased on the benzene ring. The first is resonance effect and second is inductive effects. The third mechanism also there, which is known as hyperconjugation, but here we discuss only I effect, inductive effects or resonance effects. So, if there is a group which is having plus I effect, means positive inductive effects, then they have the tendency to donate the electron towards the benzene ring by inductive effect mechanism. Okay. So, they can get so they can increase the electron density by the inductive effects. If there are some groups which is present on the benzene ring which is having minus I effects. Okay. So, they can withdraw by the inductive effects mechanism from the benzene ring, okay, and by that they can reduce the electron density on the benzene ring. So, by that they can alter the reactivity of the benzene towards the second electrophile attack on the benzene ring. The same mechanism will also be followed, but here resonance mechanism will be followed. Okay. So, the group which is having plus R effect can donate the electron towards the benzene ring by resonance, or the group which is having minus R effect, they can withdraw the electron from the benzene ring by resonance. Okay. So, if a substituent that is bonded to the benzene ring, if a substituent that is bonded to the benzene ring is less electron withdrawing than hydrogen, it will donate the electron towards the benzene ring, means it is having plus I effect. If a substituent is more electron withdrawing than the hydrogen, then it will withdraw the electrons away from the benzene ring, and it is said to be minus I effect. Like for example, as you can see in the structure, there is a methyl group. So, you know that alkyl group is always having plus I effects. So, methyl is having plus I effect. because of inductive effect, that methyl group can donate the electrons towards the benzene ring, while in case of plus NH3 group, it is having minus I effect. So, it can withdraw the electron from the benzene ring. So, in the first example, the overall reactivity of the benzene ring towards the electrophile attack will be increased, while in the second example, the overall reactivity of the benzene ring for the second electrophilic substitution reaction will get decreased. Now, how the electron donation and withdrawal by resonance takes place. So, first of all, you have to know that what are the groups which are having plus R effect, or what are the groups which are having minus I effects. So, very simple way to know that if a substituent has a lone pair of the atom, if a substituent has a lone pair on the atom that is directly attached to the benzene ring, the lone pair can be delocalized into the ring, and these substituents are called or known as the plus R group, the group which are having positive resonance effect. They can donate the electrons by resonance towards the benzene ring. Okay. So, by that they can increase the electron clouds density on the benzene. As a result, the overall reactivity of the benzene ring toward the electrophilic substitution reaction will be increased. The examples of group which are having plus R effect mainly include hydroxyl group, OR or halogens. So, they are the group which can donate the electrons by resonance. How delocalization or electron donation by the plus R group will take place, as you can see in the reaction. There is a methoxy group, it is having plus R effects, means it can donate the electrons. So, you can see that the atom which is directly attached to the benzene ring is oxygen, and oxygen having two lone pair of electrons. So, we can clearly say that OCH3 because of that having plus R effect. Because of plus R effects, these lone pair of oxygen get involved in donation towards the benzene ring. So, you can see that mechanism, these are delocalized toward the benzene ring, and we are getting different resonating structure. So, because of that resonating structure, it is more stable. Okay. So, you can see in the next slide, if the group having minus R effects, means the group can withdraw the electron from the benzene ring, it will reduce the electron density on the benzene ring. By that, it will reduce the rate of electrophilic substitution reaction towards the coming electrophile. So, how we can recognize which group having minus R effects? Very simple way, if a group which is or we can say if a atom which is directly attached to the benzene ring and which is doubly or triply bonded to the more electronegative atom, then certainly that group is having minus R effect, means they can withdraw the electron from the benzene ring by resonance. So, for example, you can see that there is a carbonyl group. Okay. If carbon is bonded directly to the benzene ring, how it is happening? Now, carbon is directly bonded to the benzene ring and it is also attached to the oxygen by double bond, okay, which is more electronegative than the carbon. So, it fulfill the condition to be a minus R effects group. So, it will show minus R effect. Again, take the example of C double bond N. If carbon is bonded to the benzene ring, as in case of COR, again it is also bonded to the nitrogen, which is more electronegative to the which is nitrogen more electronegative than the carbon, and it is bonded by double bond to the carbon. So, it will again show the minus R effects. Take the example of NO2. Okay. So, these are all having the these are all the having minus R effect. Okay. So, how electron withdrawal by minus R effects will takes place, as you can see that as here is the example of NO2. Okay. So, N is directly bonded to the benzene and N is also bonded to the oxygen by double bonds. Okay. The condition is oxygen is more electronegative. So, it can withdraw or it can pull the electrons which are shared with the nitrogen. So, this is electrons are pulled by the oxygen from the nitrogen. At the same time, the pi electrons of the benzene coming for help to the nitrogen. A double bond will be introduced in between nitrogen and carbon of the benzene, and this delocalization will continue. We are getting resonating structure by that, but overall density of the benzene ring will get reduced. Okay. Now, there are also possibility that a group having plus I effect, but it is also having minus R effect. It is also possible that group having plus R effect, but it is having minus I effect. Okay. So, at that point, if the group having relatively opposite influential group, influential mechanism, means a group having plus I effect and minus R effect, or is group having plus R effect or minus I effect, then it will be taken care that dominating force will be resonance. Then if hyperconjugation is present, then hyperconjugation, then inductive effects. Okay. इसी सीरीज में हम इसको डोमिनेट कर मतलब रखेंगे. रेजोनेंस इफेक्ट जो है डोमिनेटिंग इफेक्ट रहेगा इंडक्टिव इफेक्ट से. ओके. ये ध्यान रखने वाली बात है. So, because of that, because the group may have plus I or minus R or plus R or minus I effects, so group can behave as a moderately activating or moderately deactivating substituents also. Okay. These are the groups which can donate electron into the ring by resonance and withdraw the electron by the inductive effects, means this is having plus R effect, but the minus I effect also. For example, you can see that there is NSCO3. This is having plus R effect. Okay. Means they can donate the electrons toward the benzene ring by positive resonance effect, but simultaneously they can also withdraw the electron from the benzene ring by minus I effect. Okay. So, overall, as I said that resonance is dominant over inductive effects. So, overall effect that this group can activate the benzene ring and increase the rate of electrophilic substitution reaction in benzene. Okay. Now, the moderately reactivating group all have carbonyl groups directly attached to the benzene ring. Important point है, ध्यान रखने वाली बात है. The moderately deactivated substituents all have carbonyl groups directly, all have carbonyl group directly attached to the benzene ring. Carbonyl group withdraw electron both inductively and by resonance. It must be taken care of. So, as you can see that there is aldehyde, okay. There is ketone, there is ester and there is acid. Okay. All the groups having CO carbonyl group, and because of the presence of carbonyl groups, they are behaving like a moderately deactivating group, because they are withdrawing by both mechanism, by inductive effects as well as by resonance also. Now, this is all about activating group, moderately activating group, moderately deactivating group. Now, come to the point where we discuss strongly deactivating substituents. How? if strongly deactivating substituents are there, means they can strongly withdraw from the benzene ring, means they can follow all the mechanism to withdraw the electron from the benzene rings. Okay. So, except for the ammonium ions like NH3 plus, RNH2 plus, R2NH plus or R2N plus, these substituents withdraw electrons by all the possible mechanisms, means they can withdraw the resonance by resonance as well as by the inductive effects also. So, the ammonium ions have no resonance effect, but the positive charge on the nitrogen atom cause them to strongly withdraw electrons inductively. So, सारे के सारे जो हैं वो इंडक्टिव से इफेक्ट के थ्रू भी विड्रॉ करते हैं और रेजोनेंस के थ्रू भी विड्रॉ करते हैं. जो अमोनियम आयंस होते हैं, ठीक है कि नहीं, उनके अंदर रेजोनेंस इफेक्ट नहीं होता, तो वो सिर्फ इंडक्टिवली ही विड्रॉ करते हैं. बट दे कैन विड्रॉ सो स्ट्रांगली दैट दे कम्स in the category of strongly deactivating substituents. Okay. So, here you can see how these type of group withdraw the electron from the benzene ring. So, here oxygen is more electronegative than the sulfur. So, electron will move toward the oxygen, sulfur become electropositive. So, for helping sulfur, the pi electrons of the benzene ring will comes. Okay, will come, and by that mechanism the electron cloud of the benzene ring will get reduced. We also discussed nitro group already. We also discussed nitro group also. The same mechanism will be followed in case of cyanide ion. Nitrogen is more electronegative than the carbon. So, electron will be moved towards the nitrogen, and again pi electrons of the benzene ring will come to help of carbon, and delocalization of the electrons occur at benzene, and benzene get deactivated because of the withdrawal of pi electrons from the benzene ring. In case of ammonium ions, no resonance will take place, but they can withdraw the electron inductively more strongly. Okay. So, this is all about the effect of substituents on the reactivity. So, once again I just summarize my lecture. I have told you earlier that two types of substituents are present. Before that, I told you that when benzene itself is there, then all the carbon of benzene rings are equal. सारे के सारे कार्बन इक्वल हैं, इक्विवेलेंट हैं, sp2 हाइब्रिडाइज हैं. तो जब बेंजीन है और वो इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन के लिए जा रही है पहली बार, ठीक है, तो इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन विल टेक्स प्लेस एट एनी कार्बन, किसी भी कार्बन में हो सकता है क्योंकि सारे इक्विवेलेंट हैं. बट अगर एक बार इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन हो गया, मीन्स मोनो सब्स्टिट्यूटेड बेंजीन बन गई, ठीक है. तो जैसे घर में पापा होते हैं ना, तो दो तरह के पापा पॉसिबल है. एक कहानी है छोटी सी, दो तरह के पापा पॉसिबल है, अच्छे पापा और डिसिप्लिन पापा. ए फॉर अच्छे पापा, डी फॉर डिसिप्लिन पापा. ऐसी दो तरह के ग्रुप पॉसिबल हैं जो ऑलरेडी बेंजीन पर लग गए हैं. एक्टिवेटिंग ग्रुप, ए फॉर एक्टिवेटिंग ग्रुप मतलब अच्छे पापा वाले ग्रुप, डी फॉर डीएक्टिवेटिंग ग्रुप मतलब डिसिप्लिन पापा वाले ग्रुप, ठीक है कि नहीं. तो एक्टिवेटिंग ग्रुप वो हैं जो आपको थोड़ा छूट देते हैं कि आप ऑर्थो पे चले जाइए, आप पैरा पे चले जाइए, मन मुताबिक काम कर लीजिए, एक्टिवेट कर देते हैं, ठीक है. पापा भी ऐसे होते हैं, अच्छे पापा हैं, दोस्त की तरह रहते हैं. दोस्त आ रहा है घर में, इस कमरे में ले जाओ, इस कमरे में ले जाओ, सारी छूटे हैं, ठीक है कि नहीं. आपकी हेल्प करेंगे, ठीक है, आपके लिए स्नैक्स मंगा देंगे, चाय बनवा लेंगे, सारी चीज़ करेंगे. तो एक्टिवेटिंग ग्रुप लाइक अच्छे पापा, ठीक है, दे विल एक्टिवेट द बेंजीन रिंग्स फॉर फर्दर इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन. ओके. देन कम्स टू द सेकेंड ग्रुप विच इज डीएक्टिवेटिंग ग्रुप. दे विल डीएक्टिवेट द बेंजीन रिंग. वो ना डिसिप्लिन पापा, कोई दोस्त आया, दोस्ती आते रहते हैं तुम्हारे, हैं, दे विल स्कोल्ड यू, 24 घंटे दोस्ती करते रहते हो. दोस्त आया तो ड्राइंग रूम में ही बिठाओ, कहीं और ले जाने की जरूरत नहीं, यहीं बात करो, 15 मिनट में ख़त्म करो और छोड़ दो. तो डिसिप्लिन पापा हैं. ऐसे डीएक्टिवेटिंग ग्रुप हैं जो आपको मतलब बेंजीन रिंग को डीएक्टिवेट करते हैं फर्दर दोस्ती के लिए, फर्दर इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन के लिए. दोनों चीज़ों में ध्यान यही रखना होता है कि रिएक्शन के लिए मोटिवेटिंग फोर्स जो है वो है इलेक्ट्रॉन क्लाउड्स ऑन द बेंजीन रिंग. ये इलेक्ट्रोफिलिक सब्स्टिट्यूशन के लिए मोटिवेटिंग फोर्स है, इसी की वजह से इलेक्ट्रोफाइल अटैक कर रहा है. सो इफ़ वी इंक्रीज दैट electron cloud, or we can increase the electron density of the electron cloud, we can increase the reactivity of benzene towards the more electrophilic substitution reaction. If we decrease the electron density on the benzene ring, we will decrease the reactivity for the next electrophilic attack on the benzene ring. Again, I have also told you that activating group is always ऑर्थो पैरा डायरेक्टिंग. ओके, ऑर्थो और पैरा पे डायरेक्ट करेंगे जो सेकेंड सब्स्टिट्यूशन आएगा, वाइल डीएक्टिवेटिंग ग्रुप विल डायरेक्ट द कमिंग इलेक्ट्रोफाइल ऑन द मेटा पोजिशन. ओके, हाउ इट विल डायरेक्ट ऑन द कमिंग इलेक्ट्रोफाइल ऑन ऑर्थो पैरा और मेटा position, we will discuss in the next lecture. Okay. So, you have to taken care that three mechanism will be followed for withdrawing or donating the electrons into the benzene ring or from the benzene ring. Okay. These reaction mechanism involves mainly number 1 resonance, number 2 hyperconjugation, and number 3 is inductive effect. Okay. देन आई हैव सेड यू दैट प्लस आर वाले ग्रुप जो होंगे वो होंगे जो डायरेक्टली बेंजीन रिंग के साथ जुड़े होंगे और उनके ऊपर लोन पेयर ऑफ इलेक्ट्रॉन्स होंगे. ठीक है कि नहीं, लाइक OH, ये हमने बताया था आपको, OCH3. तो ऑक्सीजन सीधे बेंजीन रिंग के साथ जुड़ा हुआ है और उसके ऊपर लोन पेयर ऑफ इलेक्ट्रॉन भी प्रेजेंट हैं. तो ये सारे ग्रुप इस तरह के क्या रखेंगे, ये प्लस आर इफेक्ट रखेंगे, मतलब दे कैन डोनेट द इलेक्ट्रॉन टुवर्ड्स द बेंजीन रिंग बाय प्लस आर इफेक्ट. ओके, माइनस आर वाले ग्रुप वो होंगे जिसमें की एटम, मतलब की एटम वो एटम जो कि बेंजीन रिंग के साथ सीधे जुड़ा हुआ है. की एटम अपने से ज़्यादा इलेक्ट्रोनेगेटिव एटम के साथ डबल या ट्रिपल बॉन्ड के साथ जुड़ा रहेगा. ओके, ऐसे जितने भी ग्रुप होंगे वो सारे के सारे माइनस आर इफेक्ट शो करेंगे. मीन्स दे कैन विथड्रॉ द इलेक्ट्रॉन फ्रॉम द बेंजीन रिंग बाई माइनस आर इफेक्ट. तो कार्बोनिल ग्रुप वाले सारे जो सब्स्टिट्यूएंट्स हैं वो माइनस आर इफेक्ट शो करते हैं, लाइक कार्बोनिल CO ग्रुप, एल्डिहाइडिक ग्रुप, एसिडिक ग्रुप. तो it's like so many are there. Okay. Again, coming to the inductive effects. So, two types of group also be categorized, ones which are having more electronegativity than the hydrogen, ones which are having less electronegativity than the hydrogen. So, one is minus R, one is group with minus R effect, one is plus I effect, minus I or plus I effect. So, minus I effect can withdraw the electron by inductive effects, or plus I effect can donate the electron by inductive effects. So, this is the overall summary of the lecture. In the next lecture, we will discuss about how the substituents which are present over the on the benzene ring can direct the coming electrophile on the ortho, meta or para position. Okay. So, thank you so much for a patient listening. Hope you will you have enjoyed the lecture. We will meet in the next lecture where we will discuss orientation, effect of substituents on the orientation of benzene ring. So, thank you so much. Thank you.